Hello guys. Today in this video, I am planning to cover mostly all the DB parameters which are left. This video is going to be a long video, so I would request everyone to go through the entire video and check all the parameters. I'll be trying to cover all the parameters in detail as much as possible in this video. I just want to conclude this DB parameters because I think it's taking a lot of time, and once we finish the DB parameters, we can look into more interesting things which we can do with DB2. Right. So so far we have seen till the buff page. Okay. Today we are going to see from the statement heap and other parameters. Okay. So to understand statement heap and other parameters, let's go through the presentation. If you remember this diagram is from the architectural overview which we did some videos back. Okay, and the parameter we currently are looking is the statement heap, right? Now what is a statement heap and what is the use of statement heap? Now we know that whenever we execute SQL statement against a database, it has to basically compile and it has to be changed into something which is understandable by the database, right? Similar, like if when you write a C program on a Turbo C or something, you have to first we write it in a human format and then we compile it and then you execute the binaries, right? So from a human understandable language to machine level language. Now same thing happens when you execute a SQL query against a database. It has to be compiled and it has to be binded, and it has to generate a package, and then it will, using that package, it will access the data from the database. Now during compilation, that statement needs some memory. So the statement heap is nothing but the memory required by the statement when we execute the query, right, for compilation purposes. Okay, so you might have to increase or decrease depending on your need. This is a test environment, so I have set this value to automatic. Okay, the next parameter is application heap size and application memory. Okay, to understand that, let's see the presentation here. Now we know that every application, it needs some memory to execute whatever is inside the transaction, right? Now in this case, if you see, we have a work process which is nothing but an application. Okay, in this diagram you can see like 3 applications are connected to my the DB2 database. Okay, now whenever application connects to database, it will spawn one DB2 agent, okay, which in turn will take request from your application or your work process, and it will execute the whatever code you have provided or SQL statement you have provided, right? Now for this DB2 agent to work, it needs some memory. Okay, so application heap size is nothing but the memory allocated for a single agent. Okay, now depending on the workload, this agent might spawn multiple sub agents. Okay, so in this case, if you see, multiple sub agents are there. Now these sub agents will use the memory which was allocated to DB2 agent. For example, my application heap size is set to 5 MB. So 5 MB for this agent, 5 MB for this agent, 5 MB for this agent. Now this agent needs to execute some query which requires the use of parallel sub agents. Now these agents will again use that 5 MB and share it among themselves. Okay, so application heap size is nothing but your application memory allocated per agent basis. Okay, now if you sum up all this application heap size, it will give you the total application memory. Okay, now you see the parameter here, we're talking about the application heap size. So application heap size is nothing but the application memory allocated per agent. Okay, now this will be released or activated when the application connects to a database. So once the agent is done with its work or it gets disconnected from the database, automatically the heap memory of that particular application will be released to the system. Okay, now application memory is the total memory which has been allocated for the entire application. So if you have 100 application connected to database, now it tells basically that 100 application you can use this much of can divide among themselves the total memory of this much of size. Okay, so application heap is per agent, this is the sum of all the agents. Okay, stat heap size, this memory area will be used to when you're running non-stats. Okay, that is a utility to keep your system catalogs information updated for each and every table. Okay, so this particular parameter will come into picture when we do a run stats of a table. Okay, this is not very important parameter. The next two parameters, the DL check time and the log timeout. Okay, now DL check time is nothing but the deadlock check time. Okay, so before we get into this parameter, we have to understand what is a deadlock, right? Okay, so let us look at this picture. So to understand the concept of deadlock, now we have an application A and we have an application B. Okay, now application A, what it has done is, like, it has done a transaction 1, and it has updated a row on table 1. So this is our table 1, and it has updated the row 1 on the table 1. So it is marked as a tick. Okay, at the same time, what happens is application B has updated the table 2, row 2 of the table 2. So it was able to successfully execute the update statement on the table to row 2. Okay, on the next transaction, application E is trying to update row 2 of table 2. Okay, and at the same time application B is trying to update row 1 of table 1. Okay, now both this application will not be able to do the transaction 2 because when application A updated the row 1 of the table 1, let's put a lock on this particular row. Okay, and in the same way application B has locked the row 2. So application A cannot access row 2 because it is locked by application B, and application B cannot access row 1 because it has been locked by application A. Okay, and also basically they both cannot proceed, right? So this scenario is called a deadlock, where A is waiting for B and B is waiting for A. Okay, so it's pure deadlock. Both of the application cannot proceed further. Okay, it's basically like two cars banging onto each other and waiting for each other to give way, and none of the drivers, they want to move back, right? Something similar. Okay, so what is the use of a deadlock time here? Okay, now if we look at the scenario, we got the application A and the application B. Now we need to define a threshold, like when that particular scenario will be treated as a deadlock. For example, now application B might just immediately commit, right? And then application A can proceed without any delay. So the system has to detect when this kind of situation happen, at what threshold level it should think, okay, the deadlock has happened and I should try to roll back one of the application. Okay, so that threshold is defined by the deadlock check time. So it is in the default way it will be 10,000 milliseconds. Okay, so for example, the application A and application B are waiting, so it will wait for 10,000 milliseconds, and after that the database will trigger, the deadlock has happened, it will roll back the oldest application or whichever was accessing the table the last time. Okay, so that is the use of a deadlock check time. Okay, now log timeout. Okay, in this case it says seconds, but it is specified as -1. Now -1 means that it is infinite log timeout. in a sense, like if application A, let's look at the diagram here. Okay, now imagine application A is trying to access accessing the table 1, and at the same time application B is also planning to do something on this table, not the exact same row, might be a different row. Okay, but the application A is holding a lock on this table, so application B has to wait. Okay, now if I set the lock timeout to -1, that if this application A does not commit for maybe like 2, 3 days, 5 days, 10 days, this application B has to wait for those many days. Okay, so in a practical scenario, setting up -1 is not advisable. Okay, and in some of the applications I've seen, like people set this value to like 1 hour. Okay, so application B will wait for application A for 1 hour, and if it is not able to get the access on the lock or access the table, it will time out after 1 hour. Okay, so it will get some error like SQL 911, some kind of DB2 error when they run the application, like it has timed out because it was waiting on the resource, but it was not able to access the resource because it was locked by some other application. Okay, so that is the difference between a deadlock and a lock timeout. It will wait for the time specified by the lock timeout parameter. Okay, so default is set to -1, which means the application will wait indefinitely. Okay, now this can be a major problem when you set this to -1. For example, one of your application is getting hung while accessing some table. Right, and at the same time what happens is there are many applications coming and trying to access the same table. So what happens is your applications the application will start spooling. Okay, so instead of having 100 applications, because all the applications are in like lock wait, your application numbers will go like 200, 300, 400, 500, and it will eventually bring down your database and then the server. Okay, so please take extra care when you set this parameter, lock timeout. Okay, the next parameter is change pages threshold, which is set to 80. This is 80%. Okay, so what is a change page threshold? Okay, now we know that the data manipulation, it takes from the buffer pool, right? Okay, now imagine we have 15 slots here, 1 2 3 4 5, right? So 15 slots, or you say like 15 pages over here. Okay, and your data will be manipulated on this particular 15 pages. Now we know that the data is written from this buffer pool memory to the disk asynchronously, which means that your manipulation will be done maybe now, and you will get the result. The application will do some request, and the manipulation will be done in the buffer pool, and immediately you will get a reply that your transaction was done, but the data is still not written to the disk. Okay, it will be written to the transaction log synchronously, but your data from the buffer pool to the disk will be written asynchronously. Okay, now we need to specify at what time this whatever changes were written to the pages, right, to be moved to the disk. Okay, now the change threshold parameter, what it does is if you set this parameter to like suppose 90%, then it will wait like for the pages, like the changed pages level to change to 90%. For example, if you have 10 pages, then it will wait for like 90 pages of the pages to be written or changed before that is flushed to the disk. Okay, if you set it to 10%, means like one page, immediately after the one page is written, it will be moved to the disk. Okay, by default it is set to 80%. Okay, so only when 80% of your buffer pool data pages has changed, it will be flushed to the disk. Okay, so basically you are activating your some processes which will take this data from the memory to the disk asynchronously. Okay, so what are those processes we will see now. Okay, now we know what is change threshold, change pages threshold. Okay, now this particular parameter works in tandem with these two parameters, num IO cleaners and num IO servers. Okay, we have seen these parameters when we did the architecture, but with a different name, because the parameter name is slightly different from what we learned in the architecture overview. If you see IO cleaners, it means asynchronous page cleaners, and and the num IO servers. Okay, now asynchronous page cleaner and IO servers are nothing but asynchronous page cleaner is nothing but your PC cleaner process. Okay, now what it does is, like, it will take whatever the change pages were there and it will flush it to the disk. Okay, and your IO servers, what we saw, the parameter is nothing but your processes which will move the pages from the disk to your buffer pool. Okay, now there will be certain processes which will access some data, right, and it is possible that it is mostly possible that it will not be available on the buffer pool. Okay, so in that case your data has to be moved from the disk to the buffer pool. Okay, and that is done by the page PFCHR, the IO servers. Okay, so basically it will predict what data you might require. Okay, so it is basically predicting, it has a predicting algorithm, like if you have access to data 1, it is possible that you might need to, so behind the screen, before you need it, that data will be moved to your buffer pool. Okay, so that is the use of a IO servers. And page cleaner is nothing but when the change threshold is reached, those pages will be moved to the disk. Okay, so those are the parameters which will work in tandem with the change threshold. Okay, now how to set this parameter is basically depending on your CPUs, like number of CPUs, you can change this values. Okay, I usually set it to automatic because it can check the hardware setting and it will automatically change the setting. Okay, we'll skip this parameter, is not that important. Okay, now the next parameter is track mode. We have the concept to understand track mode. You have to understand the concept of backup, how the database backups are done in DB2. Okay, now we can do a full backup of the database, which basically means like entire database has to be backed up, or you have a concept of incremental backup and delta backup. Okay, so incremental backup is nothing but the changes done from your last backup. Okay, last full backup, whatever changes you have done, only the changes will be backed up. Okay, and similarly delta backup is like the from the last backup, whatever the changes was done. Okay, so incremental means the last full backup, whatever the changes were done, and delta backup is from the last backup. Okay, so the full and the last backup. Now to enable incremental and your delta backup, we need to set this parameter to on. By default it is set to no, so you cannot perform any kind of incremental or delta backup on the database. Okay, so and to enable the backup, you incremental backup and delta backup, you have to set this parameter to on. Okay, now again this parameters like max application, average application, max file open. Max application is nothing but like the maximum number of application which can connect to your database. Okay, so if you set this value to 100, then you cannot have more than application, like 100 application connected to your database. Okay, now this parameter has to be tuned in line with the application memory. Okay, you cannot set a small value and give a high number of max applications value here, right? So it has to be in tandem with the application memory. Okay, and average applications, this is nothing like the average application value. See, most of the time we have multiple application connected to the database, right? And every application will try to get the data access from the buffer pool. Okay, so this certain percentage of buffer pool being allocated to each of the application, which okay, now this value defines like how much of buffer pool memory area will be allocated per application. Okay, so more applications, then you need more memory and those kind of things. Okay, max file open. Okay, this is a very important parameter. If you see, there's a command called lsof. I think it works on Unix. Okay, so there's a limit like how many files can be opened behind the screen per application. Okay, so if your application is trying to open more than this number of files, you will get some errors. Okay, there were some bugs in, I think, in version 10.1 fixed back 1 and all, where DB2 tends to open multiple like files which will reach this limit. It will never close those files. So what was happening was, as the files were not getting closed, like after a few days the threshold was reached and the database was not at all accessible. Okay, so this is the way you can limit the number of open files. Okay, the next set of parameters are very important parameters. Okay, so let me go through that one. We look at the first three parameters first. Log file size, the log primary, and the log second parameter. Okay, now we know that whenever a transaction hits the database, it will be divided into parallel streams. Okay, one will try to get the actual data from the buffer pool, and one will go to the transaction logs, right? So transaction logs are nothing but where your actual blueprint of whatever you did against the database is stored, a copy of whatever transactions were done. So in case in future if you require those information, those can be replayed using your transaction logs, right? Now these three parameters define how the transaction logs will be laid on your system. Okay, now the log file size determine the size of individual log files what will be set to. Okay, the value will be in 4 KB pages. Okay, so the log file size is nothing but the size of individual log files. Okay, then we have two parameters called log primary and log secondary. Okay, now log primary defines your primary logs. The log second defines your secondary logs. So what is the difference between log primary and log second? Okay, now the log primary logs, it is set to 13 here, right? Okay, so when we start the database for the first time, the 13 number of logs will be activated during the startup itself. Okay, so if you go to this the log directory location, you can see 13 log files of size 1024 KB pages allocated in the beginning itself. Okay, now this log second files will be allocated depending on your workload. For example, you are doing some transaction and it has filled up all your 13 logs. Okay, and you need few more logs. Okay, now in the beginning only one log will be allocated, so it becomes 13 plus 1 14. So if 14 is also not sufficient, then 15 16 17 18 like that. So on an ad hoc basis your log secondary will be allocated. Okay, so the major difference is log primary will be allocated as soon as you activate the database. Okay, and log secondary is nothing but basically on your on demand basis. Okay, so once this limit is exhausted, your application cannot move further, or it will be rolled back, or it might hang. Okay, and one more thing is the sum of log primary plus log secondary cannot exceed 256. Okay, so you cannot have more than 256 logs on your log directory. Okay, now if you think it is not if the value 256 is not sufficient for your transactions, then you might have to increase the log file size. Okay, so take extra precaution when you increase the size of the logs, because we have a concept of archiving where you copy your transaction logs from your disk to your TSM server or your some other location. Okay, so if the size of the log file is very big, the transfer of the file from one location to another location will take time. Okay, so we have to take precautions when we increase the log file size. Okay, now so apart from this, we need to understand one concept about DB2 logging is, and we have two different types of logging in DB2. One is the circular logging and one is the archive logging. Okay, so if you see the circular logging, for example, if I set the log primary value to now 10 logs. Okay, imagine I have I've set the log primary to 10 logs, and we have set the log secondary to 0. Okay, now for example, if your transaction is starting on this log, okay, it will fill up this log. Okay, then the next transaction comes, it will fill up this log, third, fourth, like that. Okay, and for example, if I name this file as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, as soon as the 10th log is filled up, this the first log will be overwritten by the next transaction. Okay, so this file will be reused again and again and again. Okay, the downside of this circular logging is that if you want to do a point in time recovery, it is not possible. Okay, now why I say this, for example, you did some transaction on Monday on this log. Okay, and then again on all this got filled up, and again on Thursday you have reused this file. Thursday, then you did some transaction on Friday on the second log. Now you made some mistakes and you want to restore your database back to Monday, right? Which is not possible because this file was overwritten on Thursday, so we don't have any data from the Monday, right? So in this case, you cannot recover your database to a point in time. Okay, on circular logging, you can only take offline backup of the database. You cannot take online backup of the database. Okay, so this is the two downsides. One, you cannot do a point in time recovery because the files will be overwritten. Two, you cannot take online backup. You can only take offline backup when you have a circular logging. Okay, I will tell you when we move ahead with other parameters how to enable this circular logging and archive logging. Okay, so that was the circular logging. Now we will see what is archive logging. Okay, if you see in this case I have set the log primary to 10, so the log in the DB2 the log file names will be like s00.log. Okay, so as soon as your 10th log is filled, it will again reuse the other logs, same logs, so the log file name will never change in case of circular logging. In case of archive logging, what happens is, for example, this is your log s000.log. As soon as it is filled, what happens is this file will be copied to your archive location. So it can be a disk or it can be a TSM server or whatever third-party vendors. This file will be copied to the remote location, okay, the archive location, and then this file will be renamed to, for example, we have set the log primary to 10, right? So as soon as this file is copied and it is no longer required by the database, this file will be renamed to s0011. Okay, so similarly 1, 2, 1, 3, 1, 4, 1, 5, 1, 5, it will go on. Okay, now for example, if you want to restore, like you want to do a point in time recovery, it is possible because your log file is still available on your archive location. Okay, so it has not been overwritten, you still have the data somewhere on the remote location. Okay, so that is the difference. Like in circular logging, the logs will be reused. In case of archive logging, the logs are not reused, it is archived. Okay, So online backup is possible in your archive logging. Okay, point in time recovery is also possible in your archive logging. So in most of the production environment, like 99.9%, you will have archiving enabled. Okay, so only downside of this archive logging is that you need more space. Okay, and it will consume some CPU because you have to archive the logs to a remote location, and if it is on a disk, then you have to configure housekeeping so that you clean up the logs frequently and you allocate sufficient space for the archives, right? So that is the downside of your archive logging. So only the space and some CPU cycle, but when you compare it to the backup and restore, archive logging is the best solution. Okay, new log path, and if you see this path to log files, right? Now by default, the database, when you create the database, this path will be set to some location. So this is the path where your transaction log, this log primaries and log secondaries, right? All those will be located. Okay, now I can show you a quick okay, I can show you. If you see, all my logs are here, right? Okay, so okay, so you cannot change this parameter, right? If you want, suppose if you want to change this, you want to store your log somewhere else, then you need to use the new log path parameter. Okay, if you want, you don't want to use the default value, right? So this is the default here. You don't want to change, you don't want to use this parameter, then you can update this parameter to specify new location for your log path. Okay, so automatically your logs will be moved there, but it needs a restart. Okay, so you have to stop your application and you deactivate and activate the database to use the new log path. Okay, so once you change this, automatically both this parameter will change to same place. Okay, and before going to overflow log path, let's go to mirror log path. So mirror log path is nothing but a copy of whatever you have here, right? It will be stored in the mirror log path. If you set this parameter, the exact copy of your transaction logs will be stored. Okay, this is to like recover from a disk error or disk failure, right? For example, if this particular file system is on disk 1 and this is on disk 2, for some reason your disk 1 fails, right? And if you don't have disk 2 mirror log path, what happens is basically your database is gone. Okay, so in this case, mirror log path, you can always use the mirror log path because it is on a different disk and is not corrupt, right? So a kind of a redundancy of creating by updating the mirror log path. The downside is like you need additional disk. Okay, so if it is a very big disk, then money for the customer, right? So most of the times people don't go with mirror log path, what I've seen, but I highly recommend that we set the mirror log path value. Okay, now overflow log path, this parameter is mostly used during a roll forward. So some of the folks might be asking, what is a roll forward, right? Roll forward command is used to do a point in time recovery for your DB2 database. Like first, the two steps. First we have to restore the database, and then we have to specify the point in time to which you want to restore your you want to replay your logs, right? So the roll forward command will serve that purpose. What happens is, like, during the roll forward, the logs which are required for the roll forward, right, those will be moved from your third party places like your TSM server or from the disk to your overflow log path. Okay, and the roll forward command will read those logs from your overflow log path. Okay, so you can specify the overflow log path in the roll forward command itself, or if you don't specify it there and you specify the location here, then your logs will be copied here and it will be read from here. Okay, so there are two ways: you specify the path in the command, or you specify the path here. Okay, what I do is mostly in the roll forward command itself I specify the path. Okay, so that's all about the transaction logs, your log directory, the mirror log path. Okay, and before I get into this parameters, I just want to show you this parameter, the log argmath1, argmath2. Okay, this okay, these few parameters. Okay, now I told, right, we by default when you create the database it is in circular logging. Okay, now to enable archive logging for a database you need to change this parameter. Okay, so there are different values you can give. For example, in this case I've set this value to log retain. In a sense I want to enable archive logging, but in this case my archive logs will remain in this directory itself. Okay, so archiving is enabled, but all my logs will be kept here only in this location. So if anything happens to this file system, neither I will have my active logs, neither I will have my archiving logs. Okay, so this is my local system, so it's fine. Other values which you can specify here is your archiving location. For example, your database, everything is on C drive. Okay, now you have a D drive and you want to move your archive logs to D drive, so you can give D : and you can specify the path over there. Okay, so by doing that you're basically enabling archive logging for your database. Okay, now you can enable compression for your logs, or you can have some option like this server, or if you are using TSM servers you can use this option, like where you want this logs to go. Okay, and similarly we have log argmath2 parameter. For example, what I can do is I can set this value to a disk. Okay, so my archive log will go to disk, and also I can send my logs to some TSM server. Okay, so I am sending my archive log to disk, and I am also sending my archive log to TSM. So basically I have two places where my logs will be there. So in case of any corruption in one thing, I can always retrieve my logs from the other location also. Or if my logs are available on disk, it will be very much faster to access those logs in case of I require a recovery, right? So that is the use of all this log argmath1 and log argmath2. Okay, and similarly for log argmath2 you have a compression enabling, or if you want to use some TSM options, you also have some TSM options. Okay, now imagine you have set this parameter to D drive. Okay, let's think you have set this to D drive, and for some reason your D drive has been corrupted and your database is not able to archive the log from this location to the D drive. Okay, so what happens is we have one parameter called fail archive path. Okay, now if D drive is not accessible for some reason, okay, now what DB2 will do is it will do some iterations. It will try to copy it some 5 or 6 times. If it is not able to do, then if you have set this parameter, okay, then the logs will be moved to this location. For example, if I set this to parameter to E, now my archiving was going to D drive, my fail archive is set to E drive. So D drive is not accessible, so it will try for some iterations and it will fail, then the logs will be moved to your E drive. Okay, so how this works, we have one more parameter which is called num archive retrace. Okay, so it is set to 5. So in this case my DB2 will try for 5 times to archive the log to D drive. It will fail. If it fails for 5 times, the logs will be moved to the fail archive path. Okay, now what happens when D drive is back, right? So once the D drive is back, all the logs will be automatically moved from your fail archive path to your D drive. Okay, so you don't have to do anything by your own. Everything will be taken care automatically as soon as the D drive is available back. Okay, so that is the importance of all this parameter here. Okay, these parameters are nothing but for your HADR. It needs a separate session when I will be doing a HADR setup. Okay, so that time I'll try to explain all these parameters. Okay, it's very easy parameters, nothing to worry about. Okay, so coming back to the above parameters, we have here is these 4 parameters, and with these 4 parameters I'll be concluding the DB parameters. Okay, the first parameter is the block log on disk full. Okay, now what happens is, just imagine your this particular disk, for example it was on D drive, and you allocated 550 GB for your transaction logs. Okay, and for some reason your disk gets filled up. Okay, in that case what happens is, when the multiple applications coming and hitting your database, if you set this value to no and your log directory is full, right, those applications will fail immediately. Okay, so if you set this parameter to no and your application is trying to hit the database when the file system is full, those will fail immediately. But if you set this parameter to yes, okay, your applications will wait. It's like it's blocked. Okay, it is waiting for something. So what you can do is, you can go and increase the file system, or you can clean up some logs. Okay, so in that case, as soon as you like free up the space over there, your transaction will start moving. Okay, so basically if you set this to no, application, as soon as it is filled, application will fail immediately. But if you set it to yes, it will wait for you to clean up all these things, and you can continue your transaction. Okay, block non-logged operation. Okay, this parameter is very important when you set up your HADR or you set up some kind of a replication. Okay, so we in DB2 we have SQL replication and Q replication, and you also have HADR. Okay, so all this replication, what it does is, it is basically reading your transaction logs, and it will apply those transaction logs to a remote database. Okay, so it is reading your transaction logs. So what it means is, whatever is written to the transaction log will only be replicated to your remote server. Okay, now there are certain operations like load. There is a command called load. Okay, if you use the load command on your table, those transactions are not logged to the transaction log. Okay, so for example, if I'm loading one table 1 using the load command on my primary server, okay, and I'm reading the transaction log to apply those transactions to on the remote server, it is not possible, because those information about the table 1 data, whatever we inserted using load command, is not available on the transaction log, right? So it will not be replicated. So to avoid those kind of operations being done on your primary server, what you can do is, you can set this parameter to yes. So if you are going to do any kind of operation which will not be logged, your application will not move further. Okay, so this parameter will not allow you to move further unless it is logged. So you might have to change your load command to import command, which is totally logged. Okay, so any kind of operation which is not logged will be like rolled back, or you will get some error when you try to do the transaction, and this parameter is set to yes. Okay, and these parameters should be set to yes for replication environments, for HADR and all. Okay, and max log and num log span. Okay, now the use of this parameter is to kill the application when they have used certain number of logs. Okay, in case of max log, it will look only at the log primary value. Okay, now imagine if I set this log parameter to 10, okay, and I set this max log value to 90, so this value will be in percentage. Okay, so when I set this to 90 and my log primary is set to 10, now one application comes and it is doing some transaction, and it has consumed almost 9 logs out of 10 from the log primary. Okay, so basically 90% of the log primary has been consumed, right? So as soon as it consumes 90% of the application memory, immediately that application will be killed by DB2, because it is violating my max log parameter, which is 90%. Okay, so what I'm saying is none of the single application should be using 90% of my total transaction logs. Okay, what happens is if your one single transaction is using 90% of your transaction log, rest of the transaction logs, the rest of the transaction cannot do anything, right? Because everything is being consumed by a single application. So in that case, it will be a total outage. Okay, so and again, when you set this parameter, make sure that you have an agreement with your application team. Okay, simply just go and set up this parameter to whatever value you like. Okay, have a talk with your application team, and depending on your agreement, set this parameter. Okay, what I think is 85 to 90 is very good value for max log. Okay, and again, the max log is set in percentage, and it will look only at the log primary value, not the log secondary value. Okay, so if you set this parameter to 10, log parameter to 10, and it's set to 90, means 9 logs per application. Okay, it is going beyond 9, automatically that application will be killed. Okay, num log span is nothing but the sum of this for log primary and log secondary. Okay, so for example, in this case 13 plus 12, and if I set this value to 10 here, which means when it has consumed almost 10 logs, the application will be killed. Okay, so, but it takes in account of the log primary and log secondary. Okay, so let's think on a practical value. 13 plus 12 is 25. Let me set this to 20. Okay, so if I set this to 20, which means as soon as the application consumes 20 logs, okay, it's the sum of log primary and log secondary, the application will be killed. Okay, so the difference is max log only look at the log primary, num log span looks at the log primary plus secondary. Max log is a percentage value, whereas num log span is the numeric, like the number of active log files. Okay, so that is the difference. Again, to reiterate, before setting this parameter, please have a talk with the application team. Just simply don't go and update this parameters by yourself. Okay, that will get you into some trouble. Okay, so with that, I am concluding the DB parameters for DB2. Okay, in my new session, next sessions, I will be going through backup, restore, and table spaces, all those kind of stuff. Okay, thanks for watching.